Hello and welcome back to another tutorial on the University of Helsinki's massive open online course. Today we are looking at part 1 section 4, which is looking at variables. So let's begin. So the learning objectives today are to understand the concept of a variable, you know what variable types, names and values are, know how to create and use string, integer, floating point and boolean variables. Let's have a look. So above you will find a link to a questionnaire. After you have answered the questionnaire, check the box below and click submit. You'll be awarded 2 points for answering the questionnaire. I've reloaded this page and it still hasn't loaded the question, so I've just ticked it and submitted it anyway. We've already familiarised ourselves with strings to a degree while dealing with user inputs. Let's turn our attention to learning about other variable types commonly used in Java. A variable can be thought of as a container in which information of a given type can be stored. Examples of these different types include text or strings, whole numbers or int stands for integer, floating point numbers, and there they've got double, and whether something is true or false, and that's represented by a boolean. A value is assigned to a variable using the equal sign. Okay, so we've got int or integer months is equal to 12. In the statement above, the value of 12 is assigned to an integer variable called months. The statement could be read, the variable months is assigned the value of 12. A variable's value can be joined to a string using the plus sign, as seen in the following example. And remember, the plus sign allows us to do concatenation. So here we've got string text, int whole number, floating point double, and a boolean, which is true or false, set to true. Here are the system outs, and then here we can see how that would appear in our console. So the first exercise that we're looking at today is called various variables. You'll note that I've already got my point. That is because I forgot to record it while I did it, but don't worry, I've put it back to the beginning and I will go through that with you. So let's open our TMC NetBeans. This is the various variables code. And remember, that can be accessed on the left by going to source packages, default packages, and then the class various variables if you double click on that. And we've already got this code in here, and we just need to update these 3 variables with the correct information. So I'm going to move my screen to the side using the Windows key and left button, and then on my other screen I'm going to select the various variables. Just going to drag this over so I can see properly. So modify the program in the given places so that it outputs the following. So chicken needs to be 9,000. So here is the integer for chicken. So let's change that to 9,000. Bacon needs to be 0.1. It's currently 5.5. So let's change that. And then tractor needs to be changed to zeta or zetor. So let's change that. There we go. So let's give that a play. So that runs, that's absolutely fine. What I will quickly do is submit that as well, just to make sure that everything's still okay on the server side. And there we go, that's passed the test. So we can fill out our results table and okay that and send it off. So I'm going to right click and close that exercise, and then let's just maximize this window here. Okay, so variable names are unique. No 2 variables can have the same name. The program in the following example is faulty as it attempts to create the variable pi twice. The variable is created the first time it's declared. So here we've got our main, and then we've got double pi equals 3.14, and then we've got again double pi equals 3.14 but more decimal places. Coincidentally, if we just wrote pi and got rid of that double section, it would update the value of pi here with this new variable, with this new value, sorry. So if I go back to NetBeans, I'll show you quickly what I mean. Okay, so let's get rid of this old code. So we had double pi equals 3.14, and then we had double pi again. But if we put pi equals, and then we'll copy it because I don't know it to that many decimal places, like so, And we can test this theory, so we can put an S out here and print pi, and that will print the value as it is on line 6. And then we can print pi again, and it will print out the value as it is on line 9. So if we quickly run that, there you go. So you can see the system out on the first one has given us the value of 3.14, and then the second time it's given us the updated value to more decimal places. Just going to increase my font sizes just so hopefully you guys can see properly. There we are. Excellent. So let's see where we're up to next. The variable type is stated when the variable is first declared. When a new value is assigned to the variable, the type is no longer declared. So here we've got a integer example. So we've got int value equals 10, and then they've done what we've just done and used a system out to show the value here, so it would print out 10. And then here we're updating the value with the number 4, and then system.outprint value. And you can see here it did exactly the same as the double and printed out its first value and its second value. Changing a value assigned to a variable. A variable exists from the moment of its declaration, and its initial value is preserved until another value is assigned to it. You can change a variable's value using a statement that compromises the variable name and equals sign and the new value to be assigned. Remember to keep in mind that the variable type is only stated during the initial variable declaration. So here we've got another example. So we've got initial number is equal to 123 or 123, and then a system out which prints out this string and then the variable, and then the variable is updated to the number 42. So this 123 is gone and it's now 42, and then it will print out again the value of the variable is 42. So let's look at the preceding program's execution step by step. When a variable appears in the program for the first time, the computer is told both its type, in this case int, and its name, in this case number. The computer creates a named container for the variable. Then the value on the right side of the equals is copied into this named container. So here is the computer creating the variable, so int number, and then the value 123 is assigned to the variable number. Whenever a variable is referenced by its name in a program, here we want to print the string the value of the variable is, followed by the value of the number variable. Its value is retrieved from a container that has the corresponding name. So here we've got systemout.print the value of the variable is plus the variable name, which looks up here, finds the name and their corresponding number. Whenever a value is assigned to a variable, here number is equal to 42, a check is run to see whether a container with the given name already exists. If one does, a new value is copied in the place of the old value, and the old value disappears. If a container of the variable name is not found, the program execution ends in an error, or it fails to run. So it will fail to run on the line where it just says number equals 42, because it hasn't got a variable declaration. Because it hasn't got a data type declaration. The variable is then referenced again by its name in the program. We again want to print the string, the value of the variable is, followed by the value of the number variable. We proceed as normal, retrieving the value of the number from a container having its name. At the end of the program, you'll notice that the original value of the variable has vanished. A variable can only hold one value at a time. Once a variable's type has been declared, it can no longer be changed. For example, a Boolean value cannot be assigned to a variable of the type integer, nor can an integer be assigned to a variable of the type Boolean. So here we've got an example saying Boolean integer assignment will work, it says false, integer assignment will work equals 42 does not work. So here we've got that name, and then there we're trying to assign a number to something that can only be true or false. Okay, and then here we've got int value is equal to 10, so that's correct because it should be an integer value. And then here we've got integer assignment will work equals value, it doesn't work. So remember, integer assignment here is originally declared as a Boolean. However, exceptions do exist. An integer can be assigned to a value of the double type, since Java knows how to convert an integer to a double during assignment. So we've got the example, double floating point equals 0.42, floating point equals 1, and then int value 10, floating point equals value. A floating point value cannot, however, be assigned to an integer. The reason for this is those who develop the language aim to prevent developers from making errors that lead to a loss of information. So changing a variable's data type from one to another is called casting, and you have widening or narrowing casting, which is something maybe to have a little look at. Okay, so naming variables or naming conventions. Naming variables is a fundamental aspect of describing a program. Let's look at two examples. So here we've got double A, double B and double C. Double A is equal to 3.14, double B is equal to 22, and then double C is equal to the value of A times B, and then the value of C is printed out. But you're not really getting much context. We don't know what A, B and C are. We could hazard a guess and say that A is pi, and that this is working out a surface area. So double A in this example has been renamed to pi, double B has been renamed to radius, and double C has been renamed to surface area, and then the equation makes more sense as well. So it's equal to the value of pi times the radius. Both of the preceding examples function the same way and output the same result. One of them, however, is much more understandable. The objective here is to compute the surface area of a circle. The value of pi is defined in the first row, the circle's radius in the second, and the surface area calculated in the third. Programming is a problem-solving tool. The aim is to create solutions for any given problem, such as the automation of controlling cars. As a problem is approached, the developer decides on terms used to describe the problem domain. The terminology that is chosen, such as variable names, will serve to describe the problem for anyone who is to work with it in the future. As you are wording the problem that you are solving, think about the concepts related to that problem and appropriate terms that could be used to describe them. If you find it hard to come up with relevant names, think of ones that definitely do not describe it. After this, settle on some terminology that you're going to use. The good thing is that you can usually improve on this later. So variable naming is limited by certain constraints or restrictions. Variable names cannot contain certain special symbols such as exclamation marks. Spaces are also not allowed since they are used to separate parts of commands. Instead of spaces, the convention in Java is to use a style name as camel case. Note the first letter of the variable name is always lowercased. So here we've got a variable, and you can see that the C of camel is lowercase, but the C of case is capital and the V of variable is capital. So for example, if we were to write a variable here, so let's say a string, so we could say username, and then you can see that I've used a lowercase u and an uppercase n. We could do first name, same sort of thing. We could do last name or family name, whichever you want to use. And we could even write a sentence using camel case. And the idea is that the capital letter of the new word signifies the end of the previous word, so it should make it a bit easier for you to understand. So if we start so here we've got quick brown fox jumps over, and then it could continue, but you sort of get the idea that that's camel case. There are different types of naming convention as well, but I'm sure we'll look at those later in the course. Numbers can be used within a variable name as long as the name does not begin with a number. Also, a name cannot consist of only numbers. So here we've got int 7 variable equals 4. That's not allowed, that would throw an error. But we've got int variable 7 equals 4. And that's fine because they've used the number at the end of the variable name. However, it's not a very good name. Variable 7 doesn't really mean anything. A variable's name cannot already be in use. These names include, for instance, variables previously defined in the program and commands provided by Java. So, for example, we couldn't use system.out.print and system.out.println there. So, and normally your IDE is quite intuitive. It will tell you if you're using these reserved words. So for example, I couldn't create a string called int. I couldn't create an int called void. And you can see when I'm typing some of these keywords in, they're coming up in blue, and that signifies that they are a reserved word. Letters containing diacritics, such as a and u used in Finnish, should not be used in variable names. You can replace these letters with their non-diacritic equivalents. For example, you can convert the a to a and u to o. Permissible variable names. So here we've got last day of the month equals 20, first year 1952, and name Essie. So these are all acceptable. Impermissible variable names. So we've got last space day space of space month. That would not work. We've got one day, because that starts with a number. That won't work. Beware with an exclamation mark. Cannot use special characters or that special character, so that won't work. And then we've just got here a data type full of numbers. So 1920 is equal to the value 1. So again, we cannot use that. A variable type is specified when it's initially declared. For example, a variable containing the string text is declared with the same statement, string equals text, and an integer having the value 42 is declared with the statement int value 42. A variable's type determines the types of value that can be assigned to it. String types hold text, int type hold numbers, and double floating point numbers, and Boolean types are either true or false. As such, the possible values of a given variable type are limited. For example, a string cannot contain an integer, nor can a double contain a Boolean. So here we are, we've got some examples of whole numbers and the accepted values. We've got floating point values and their accepted numbers, which are huge. We have string. So string's quite interesting, so it can contain anything, provided it is within the double quotes. So say for example you put a number in between double quotes, that's perfectly acceptable, but you wouldn't be able to perform mathematical operations with it because the compiler, because Java, would recognize it as a string. And then here we've got Boolean, which is always represented as true or false. In the text-based user interfaces that we've used in our programs, the user's input is always read as a string, since the user writes their input as text. Reading strings from the user has become familiar by this point. We do it using the next line command of the scanner helper method. So here we've got our scanner called scanner, and then we're assigning the value of the next user input to the variable text. Other input types, such as integer, doubles, and booleans, are also read as text. However, they need to be converted to the target's variable type with the help of some tools provided by Java. The integer.valueOf command converts a string to an integer. It takes the string containing the value to be converted as a parameter. So here we've got a string, and then here we are reassigning it to an integer. When using a scanner object, the reading of the value is usually inserted directly into the type conversion. This happens like so. So here we've got scanner equals new scanner, system.out.println write a value, int value equals integer.valueOf, and then scanner.nextLine, and then it prints out what you've written. So here are a few examples. Write a program that asks the user for a value. The program should then print the value provided by the user. So here's a few examples. So we need to have a system out saying give a number, e input opportunity, and then system out printing out our data variable. Okay, so let's go to our project. Okay, let's just have a quick refresh of my memory and see what the... So we've got integer input, give a number, you gave... Okay. So you've given us an example of... This was a piece of code that I put in for other video that I recorded, or that I thought I recorded, and it shows casting, narrowing and widening casting. So here we've got a double called EG of the value 9.2, and then systemout.print EG. Here we've got EG being assigned to value of EG1, and we're telling the runtime that the variable after int is to be passed as an integer. So if I play that, see here we've got 9.2, and then this has been parsed to an integer, but we've lost the precision. See, we've lost the 0.2. So I'll just clear that off my screen, and we can get ready to complete this code. So I'm going to have to flip back to the code now because I've already forgotten what we're meant to be doing. So I'm just going to copy this example, and then I don't need to worry about flipping back. So we need to give a number. So give a number. Remember to put your set your colon mark there, and then they're expecting an input, and that is going to be stored in a data type of integer. So there's a couple of ways that we can do this. In the course, we've been shown to do it this way. So int input equals, and then integer value of, etc. But you can split this. So we could do here int input. So we've created our variable, and then down here we can say input equals integer dot value of, and then we can put our scanner reference in there. So scanner let's see. So scanner dot next int. So I need a capital I there. And I put 3 n's in scanner. Let's get rid of that. Okay, and you gave the number 3. So let's put another system out in. You gave the number, and then plus input. Okay, so let's give that a run and see what happens. Okay, so here we've got an error, so it must be a typo. Let's have a look. So you gave the number expected. Let's just quickly look back at their example. Oh, okay, so I've put a colon, and I shouldn't have. So here on this line there is a colon, but on this line there isn't. So let's just run that again. Okay, so we've got another error, which is integer input test. Input converted to integer. So here I've put next int, but I imagine it needs to be entered as a string and then converted to the integer. So let's just try that. Perfect, and that is done. So we can OK that and send that data off. And consequently, there is another way that we can write this, and it is the way that I tend to write it. So we can say input is equal to scanner dot next int, like that. And you can see it's a lot shorter. It's not quite as verbose, i.e. it doesn't use quite as many words. So if I print that out just locally, you'll see it has the same effect. So here we'll give a number, and we gave the number 4. So now it's expecting another number, and you gave the number 5. So it doesn't make any odds, but if you try to complete your code with this particular type, you'll get that input mismatch exception that I literally just got in the previous submission. Okay. So that's finished. We can close that one down now. There we go, and then we're getting ready to move on to double input. So let's go back to the course. Test the functionality of your program with non-numerical inputs. The program should break as it doesn't know how to convert these inputs into numbers. We'll learn how to deal with exceptional cases like these in the advanced programming course. So reading doubles. The double dot value of command converts a string to a double. It takes the string containing the value to be converted as a parameter. So there's the example. So you notice it's very, very similar to the previous example for integer, except for the words integer are replaced with double. So here we go. Write a program that asks the user for a floating point number. The program then prints the user's input value. And then we've got our example here. So I better copy that because I'm sure I'll forget otherwise. So we are in the correct exercise. Let's see. There we go, double input. Just paste this in here. So the first thing we need is our user prompt. So system out, give a number, remember the colon there. And then what we need is a scanner. So we need to use our scanner. So we can say double input is equal to double dot value of, and then we can do scanner dot next line. And at the end of the line we need to put our semicolon, and then we need the final output, the final S out that says you gave the number a space, no colon, plus input, and input because that's the name that we gave our variable. So I'll delete these, give that a test, let's run that and see how we do. Excellent, and that time we passed that one first time, so that's good. Get that one sent off, close this project, and back to the course. So let's see what's next. So booleans. So remember, a boolean is a true or false value. The integer.value of command converts a string to an integer, and the double.value of converts it to a floating point. The value of command also appears when converting a string to a boolean. This is done with the command boolean.value of. Boolean variables can either have the value true or false, and notice that they're lowercase as well. When converting a string to boolean, the string must be true if we want the boolean value to be true. So it must be the value of true. The case is insensitive here. Both true and true return into the boolean value of true. All other strings turn it into boolean false. Okay, didn't know that. That's an interesting fact. So let's head back to our code. I'll just copy this. Just to show you as well, on the last, I'm in Sandbox here, see. On the last double input, I didn't show you what the sort of shorter way of writing the code is. So I'll just post this in, and I'll show you when we're doing this example. So we need our prompt, and it is write a boolean, and then we need our scanner. So I'm going to show you the double one just very quickly. So we could say double input is equal to scanner dot next, and this time it would be next double, like that. So the scanner class has a lot of next methods, and that is one that you can use. So I'm just going to delete that, and I will enter the Boolean version. So let's do Boolean input equals, and it will be Boolean dot value of, and then in there will be scanner dot next line. In fact, actually, when we type in dot next, you can see all these different options it gives you. So you can see all of the different use cases that you've got there, all the different uses. Okay, and then we need to print out the answer. So you wrote plus input. So let's send that off and see how we did. Whoops, looks like I wrote the wrong input here. So it said it should be write something, not write a boolean. So let's do write something and then get that sent off. Oh, I'm not doing very well this time. So here, it was meant to say true or false, but I wrote, you wrote. So let's just quickly change that. So true or false. Let's test it again. Third time lucky. Okay, so I didn't put a capital T here. So let's just change that. Fourth time lucky. There you go, we got it this time. Excellent. So let's OK that. So there is another way that we can do this as well. So what we can say is scanner.next boolean. As simple as that. And it makes the it makes your code a little bit shorter, a little bit perhaps more efficient. Okay, so let's get this one closed down. And then, so the next part is different types of output. Let's see. Oh, I copied the wrong bit, that's why. I got it wrong so many times. So, here's a summary. So this is showing us all the different options that we've been through so far. So we've got integer.valueof, double.valueof, and boolean.valueof. So the final exercise is to write a program that asks the user for a string, an integer, a floating point number, and a boolean. The program should then print the values given by the user. Okay, so we've got 4 prompts, 4 different scanners, and 4 different outputs. So let's get coding. Right, I'm going to copy this. Definitely the right one this time. Let's open up our different types of input class. There we are. And I'll just paste that in down there, and then we can start writing the code. So the first thing we need to write is a string. So the first thing we need to write is a system out that says give a string. There we go. And then for that we will need string input. We'll call that S input with a capital I, so that's camel case. So the S stands for string, or we could do str. So string input equals scanner dot next line. Oh, so they've changed the scanner name to scan. There we go. Then so we can delete that one. Next one is an integer. So system.out give an integer, and then we're going to need int I input equals integer dot value of, and then inside the parentheses it's going to be scanner dot next line, like that. Sorry, it's going to be scan dot next line. Then we need to do a double, so s out give a double, then double d input equals double dot value of scan dot next line. Then we need to do the boolean, so s out give a boolean, then boolean b input equals boolean dot value of scan dot next line. Whoops. There we go. And then we need to print out the output statements. So the first one is you gave the string plus string. So we'll copy that. Then we need the integer one. Then the double one. And then finally the boolean one. Okay, so I need to make sure they have spaces at the end. Hopefully that will pass first time. We shall see. Let's give it a run. Okay, so we've got a fail. Let's have a look and see how we did. So, output on line 5 was incorrect with the input. Oh, of course, I haven't put the variables on the end, have I? So we need to do plus string input, we need to do plus I input for the integer, plus D input for the double, and then plus B input for the boolean. So let's give that one a run. Great, so that has gone through. Okay, so we can click OK on that one. Let's close the class there, the package, and we can head back to the course. Remember to check your points from the ball in the top right hand corner, so let's refresh these, have a little look. So we're nearly halfway through the first part, so that hasn't actually taken too long. Each of these videos are about 20, maybe 30 minutes. I think the first one's a bit longer, so they're not taking us a huge amount of time. The next section, 5, is calculating with numbers, so it looks like we're going to be doing a bit of maths. So we'll have a look at that next time. But again, thank you so much for watching. If there's anything else that I can help with or explain in a bit more detail, please feel free to add a comment. But until next time, happy coding!